Alright, so Q2. Okay, so I am calling Q2 graphing quadratic equations, and we are going to graph them within vertex form, and then we're going to do standard form. Okay, so basically you're just graphing quadratics today. That is cool. Okay.
Wait, go back up.
Oh, we're still stuck on the title? Yep. In vertex and standard form.
I'm just trying to transform quadratic. How many steps are you at? What? How many steps are you at? 6,000?
7.
7,000?
Yeah. Alright, next thing you're going to write down is the vertex form. Okay, so vertex form is g of x, or whatever you want it to be, is equal to a times the quantity of x minus h squared plus k. No, that's the best. You've probably learned this before, yes. It's been 1 whole year since you learned this last. Probably less than 1 year, actually.
Is it like inside is like actually like the opposite?
Alright, so why on earth do you think they might call it vertex form? Because you can literally pull the vertex straight out of it. Okay? So the vertex is simply h and k. Now notice, the function says x minus h. Okay? Which gives us a positive h value. Okay, take note to that, because that is important. Okay. The h becomes a positive value in that scenario.
It's negative if it's actually. Yeah.
I remember this. So then the h will always be like the x from your will always be the
Of the vertex, correct.
Of the vertex. Okay.
Yep. So h and k are specifically used for vertices of any function. Okay, so the cool thing about this scenario is that it not only works for quadratics, but it works for all polynomials. Okay, so eventually we'll do not just quadratics, but cubics, and quartics, and quintics, and so forth. Oh, we're gonna, and you will like it. Alright, let's do an example. Jenna, are you listening?
Yes.
Are you sure? Are you writing any of this down?
Whoa.
She's actually writing it down on her card, so she can. That's actually rather impressive.
Yeah.
I don't get the.
Are you okay?
I'm really confused what the X
That's like
What it means? It's like a y.
Like a function.
So you know how you have y equals? Well, the only thing, it is slightly more informative than a y. Like usually you've seen y equals. Well, f of x means I have a function. That's why they use the letter f for function. And then in terms of x, which tells us that the variable that's going to be used is going to be an x. As opposed to an a, or a c, or an m, or a t, whatever. You can use any letter for a variable. Okay. So, all we're doing in this section is graphing, right? Okay. So the first thing that we need to be able to find is the vertex of our parabola. Okay, which is either the minimum or the maximum of our spot, right? Okay, so can somebody tell me what the vertex of this particular parabola is?
-2,
-2, -4.
If it's positive,
Okay, so remember how the formula was a minus? Okay, so if it's a plus, it's always opposite. Okay, the way I remember is I always think, if it's in parentheses, It's opposite of what you would think.
Okay.
Okay? So, if I have a vertex of -2, -4, what are the directions that would take you to -2, -4? Go ahead, Jenna.
Down and left.
Close, but opposite. Well,
Right?
like say it the other way. There you go. Because this one, because you go left, and then down. Okay, so we're gonna go left 2 and down 4, right? All right, so left 2, down 4. Okay, now here's the rule, and this is a nullity rule. Are you ready for my rule?
Maybe.
A nullity rule. Okay? You should probably write this
We'll
down.
try it.
Okay, when you are graphing functions, okay, so any polynomial, you need to plot 3 points. Okay, so I need to know what the vertex is, and I need 2 additional points. Okay?
Is that too low?
Polynomial, like a quadratic, any equation. If you're going to graph something, you need 3 points.
Oh, that's not a nullity rule, that's like an every math teacher ever.
You just got
You're good. I thought it was like some special way to help
It's a
us
nullity rule
like
in my heart.
really get this. Nullity.
It's okay. I still love you.
Thanks. I'd appreciate that.
I like to see that fight.
All right, so we all agree that this is the vertex is -2, -4. Okay, so help me out. How could I potentially find an additional point?
To get something in.
What?
Yeah. Well, congratulations.
Plug something in, right? Okay, so plug something in. What would be a good number to plug in? Because
0, 0.
5.
0, 0?
Oh, just kidding. Sorry. I thought, sorry. 1 and then.
Okay, so let me tell you. When you are picking a number to plug into the function, you want to choose an x value that's really close to the x value of your vertex. Okay, if you get too far out, like if I chose 5, for example, 5 would result in a really large y value, which would be way off of our graph. Okay, we would get an answer, but it would be really far away from our vertex. Okay, so give me a good x value that would be close to our vertex. -1.
You're -1.
Sure. Okay, so all I have to do is do f of -3, so I'm just plugging this into the x value. Yeah. Okay, so just a basic input-output scenario. Okay, I could come up with a complete graph if I put in a whole bunch of x values. I'd eventually know what everything looks like.
Wait, you press it.
I forgot what.
Is there an A?
There is an a, it's just not written. It's invisible. It's a value of 1.
Why didn't you write it?
Because do you usually say 1x? Okay, so what's -3 plus 2?
-1.
What's -1 squared? 1. And what's 1 minus 4? So would we all agree that I just found the point -3, -3, Carson?
Yeah.
Put down the marker.
Wait, so
There you go.
since it's negative x.
Right, that's an ordered pair. We just plug that in. Okay, so if I plot this, it would be right, let's see, -3, -3 right there. Okay, and make sure when you graph these that you label your points. Don't just put them down because it's sometimes hard to tell where you're putting points. Okay, now how could I really easily come up with a third point?
Just do it on the other side.
Okay, what do you mean by the other side?
Just do it on the other side.
Just do it on the other side. So, okay, so what you're not really saying but you are understanding is that a parabola has an axis of symmetry, right? It's completely symmetrical, okay? So there is like this invisible line that goes directly through the vertex called the axis of symmetry.
I remember that.
Axis of symmetry. Okay, and you're going to be asked to write the equation of the axis of symmetry. Okay, now the axis of symmetry is always a vertical line, so how do all vertical lines always start? X equals. Okay, and all you would have to say is x equals, what is the x value that it goes through? -2. Okay, so all I have to do now is take that point, reflect it over the axis of symmetry, and where would it land?
You just do the slope of what it is right now.
Hold on. So -1, -3. I don't know.
It's just up one, right one.
Okay, let's talk about that. Okay, and make sure when you're drawing a parabola that it looks like a curved function as opposed to a straight edged function like a V. You would be amazed at how many V's I see when we're doing quadratics. Okay, so make sure you have curvature. Parabolas are curvy. Okay, now let's talk about what you said about slope. Okay, so Kaya threw out this word slope. Okay, and she said, well, the slope is just 1. Can't you just do up 1 over 1? Okay, would that work? What do you mean? Give me more information. Up 1 over 1 from where?
The vertex.
From the vertex? So I can just go up 1 over 1, and I would just simply land at the point -1, 3.
But it has to be the same slope as the other.
But it has to be the same slope as the other point. Okay, fair enough, because it's a reflection over the axis of symmetry. But that would give you a straight line. So, but it does go up 1 over 1. But it's not the same. Do you know what word is used to describe the same? Okay, so the word that we're looking for is constant.
I knew that.
Constant. Okay, so you're right. The slope is not constant. If I kept going up 1 over 1, and up 1 over 1, and up 1 over 1, I would draw a straight line.
That's not.
Okay? But a parabola, we can use some ideas, and it does work. We can use the slope if we are 1 horizontal unit away from the vertex.
That's what I'm saying. So like, if you drew another point, say it was
From -1, -3,
the vertex.
from the
Like, if we
vertex.
just look into the equation, we got a whole different form.
Right, okay.
And then we graph that on one side.
Yep,
And then you could just like find the slope of it on that side and find that on the other side.
yes,
That's fine.
yes. You are correct.
Not like up 1 over 1, up 1. That would just create one.
Right.
Right. I just have to remember myself.
Yes.
How do you get on that problem? How
Yep.
did you get the dot on the, like, how did you get, like, the other?
This red one?
No.
This
That's the
blue
first
one.
equation. Yeah, oh,
This
yeah.
blue
and
one
then
or this
here,
blue?
and then here. That's how you do it, and that's here. Do you, like, you just have to put one on exactly the other side?
You just mirror the one. So if you do the method where you plug in a number, then so we got the point -3, -3. So then all I did is I took that and I reflected it over the axis of symmetry. Okay, so the axis of symmetry is 1 unit away from here because I know it's at -2. So I knew I had to go another unit away, and the height will always stay the same.
Okay. So the vertex everything?
The vertex is slightly given. You pull it out of the original form.
Okay.
So yeah.
I think I get this.
Okay.
Which is good.
Let's do a couple more and see if we do get this. Okay, let's say this time my function is -2 x minus 4 squared plus 1. Okay, so tell me about this. Let's start with the basics. Let's start with the vertex. What is the vertex? So 4, 1. Okay, now tell me about the movements. What is the horizontal movement that we would take to get there?
Right.
To the right. So we go right, 4, and up 1. Perfect. Okay, and it's important that you understand that this is technically a translation. Okay, but we can use the vertex to get there. It's a translation. It is shifted. It's a parabola that is moved to the right, 4, and up 1. Okay, so our vertex is 4, 1. Okay, so before I start, I want the axis of symmetry. I'm going to draw this vertical line. Whoops, I totally missed. My axis of symmetry is at x equals 4. Perfect, okay? Okay, so now I need 2 more points. How would I come up with 1 more point? Okay, sure, I could plug in 3. Let's plug in 3. Okay, so I'm going to do this off to the side. So I have -2, and I'm plugging 3 into the x. Okay, so I have to deal with my quantity first. So 3 minus 4 is -1, and -1 squared. So -2 minus 1.
But that rule doesn't apply.
What rule?
With entire physicists, right? You know, I do the opposite of the 4. You don't have to do that.
Oh, no. No. So what's the point that I just found?
3 negative.
3, -3. Everybody okay with that? Okay.
And you solve inside of
3, -3. Hold on, what happened?
Yeah, how did you get the negative 4? So
3 minus 4.
Well, yeah, but why would, yeah. No, because it says -2.
3 minus 4.
Well, it says +1 on the end. Yeah, you.
Oh, I changed it. Okay, good. I knew I made a mistake, but I couldn't find it. Thank you.
Okay.
Good catch. I just can't copy down from the next step. Okay, so -2 plus 1 is -1. There we go. Sorry, my mistake.
So it's 3 negative 1.
So it's 3 -1. We all okay with that?
Yeah.
Okay, so 3 -1 is right here. So if I take that and reflect it across my axis of symmetry, where is it going to land? Where's my point going to land?
5.
5, -1. Good.
What's the first 3 negative? And then from there you can just draw your.
Probably. Yep, I'm only asking for 3. Okay, so let's use the idea of the slope. Would the slope have worked? Okay, so what is my slope technically in this scenario? Two, 1? Well, what's just the A value? -2. Okay, so how would you do a slope of -2? Down 2 over 1. Are you guys okay?
Yeah,
Dawn, do you mind just sitting in another spot? Is that okay? If it's no big deal. Okay. You can sit by Megan. I bet she won't bite. I don't know. I'd be a little worried. Okay, so everybody see that my slope is -2. You see where I get that from? My A.
So A is the slope.
A is the slope. Okay. Yeah. Yeah. So let's say I didn't do this part right here where I picked a number and plugged it in.
Okay.
So I found my vertex and I was just looking for another point. Okay. So you can also use the slope to get to this other point. Okay. So if I have a slope of -2, my movement would be down 2 over 1. Okay, so from the vertex, I would go down 2 over 1. And I would land exactly at 5 -1, and I could reflect it.
So you can only do that from the vertex.
You can only do it if it's 1 horizontal unit away from the vertex.
Wait.
Do you want me to say that louder?
-2. Wait, that would never happen.
Go through examples where it went.
Okay, I will do one. So let me write this really quick. So -2 over 1 only works. So you would go down to 1.
Wait, there's no B though. The A is never going to be, well, I don't know, but it's never going to be like -2. So it was
Why
like
not?
a number.
It could be.
Yeah, but like, most like,
Right.
like
It's usually
So
not.
if it's a whole number, then you could do it.
Right. Yes. Okay, so let's do it in a scenario where you can't do it that way. Okay, so,
I'm gonna write that down.
okay. Good?
Yeah. No. Why are you the only one doing it?
She's not the only one.
I'm just joking.
Good? Okay, number 3. Okay, let's say this time you have 1/2 x plus 3 squared minus 2. Okay? So I'm going to stop for a second. I want you to graph it. Okay, so on your piece of paper, I want you to find the vertex in 2 additional spots, points. Ready, set, go. Right.
I hate fractions. I can't
You
do
can find the
math.
vertex, though.
Fractions in problems I sit down.
My brain.
Like I have a heart attack, I only like skip over the problem like that.
Uh-oh, you have fraction anxiety?
Yeah, I do.
You have FA?
Yep.
Maybe we need to do some fraction work.
No,
No,
that's okay.
we're good.
What if she-
Fractions are incredibly easy. You just have to understand them. Okay, graph this. Find the vertex. That's the easy part. Start with there. Make an educated guess on how you can find the 2 additional points. Okay, if you don't like the fraction, then just pick a value and plug it in.
What does that number mean?
What does the number
Yeah,
mean?
so the last one there was a 2.
Yeah.
So wait, so the vertex is
Not like that.
why was 5?
Presley, the answer to your question about that number in front of the parentheses is your a value, which affects the slope of the parabola.
No, it's the vertex.
All right, you guys ready? Everybody done? You got one?
Hold up, stop.
What? The function of 2? Like f of x equals 2? Oh, I see what you mean. Yes, you can do that. I don't know if I would choose 2, though. Because the vertex is -3. -3, -2. ready? Okay. So for starters, did everybody get a vertex of -3, -2?
Yep, I got that.
Okay. And so quickly, and I didn't ask you to do this, but the axis of symmetry would be x equals -3. What?
Wait, how is it? Oh, because it's, yeah, I got it. Yeah, yep.
Good? Okay.
Sure? Yeah, because it's just the one on the, yeah.
Just the x value, right?
Yep.
Or the h, technically. Okay, so at this point I'm going to throw it to you. How did you find an additional point? What did you do?
I did -2. I did -2.
So people are just plugging in points? Okay, perfect. Okay, so if I plug in -2, I would have 1/2 -2 plus 3 squared minus 2. So -3 plus, or -2 plus 3 is 1, 1 squared is 1. So I get 1/2 minus 4/2. Because 2 is the same as 4/2, right?
Why would you do 4 halves?
That'd be 1 1/2. 4/2 is 1 1. Why can't you just
Why
say
can't
2?
you choose calculus?
Why? Oh, just because I like to play with fractions, and that's really easy conversion. 2 is the same as 4/2, and then I have a common denominator, and that makes -3 halves.
What? Oh, I see what you did. I got it. I didn't get that at all.
Okay, so
Yeah, I got -1 1/2.
So we could have done that with the fraction, or not a fraction.
You're right.
Yeah, what a bit.
half times 4/2.
I just changed mine to a decimal.
Sure.
I got 1/5.
I just prefer fractions.
Multi, I got 1.
Understand what?
I got 1.
I did.
Did you get -1/2, or did you get 1/2 minus 2? Did you get to that part? 1/2 minus 2?
Oh, I did. -2 plus 3 is -1 squared.
Well, +1.
Yeah, that's what I'm understanding. How do you plot those?
How do you plot a fraction?
Yeah.
If it helps you convert it to a decimal. Because -3 halves is the same as -1.5.
Wait. And then you do 1 minus 2, I thought.
What?
Or you do 1 times 2. 1 minus 2.
No, 1/2 minus. So, okay, so I have, we're right here, right? So this is, what's 1/2 times 1? 1/2 times 1.
1/2 times 1.
So 1/2 minus 2. What's 1/2 minus 2?
Same as your halves. Sorry.
Where are we?
Yeah. It's -1.5. Does that help you think in
Yeah, I
decimals?
did 1 minus 2 first.
Oh, yeah, no, don't do that.
Yeah, exactly.
You gotta do multiplication first. Okay, so we get the point, did we finally all agree on the point -2 and -3 halves, or -1.5? So we get this point right here. So what would be my third additional point?
Is it going up?
Yes.
So it's -4.
And then the y value is the same.
Is the green in between? Okay, how is it going up?
The green, the red. The
Yeah.
red is the axis of symmetry. What? What's negative? The A value is positive. The A value is, there's not a negative in front. The only way for the parabola to go upside down is if it was a negative 1/10 on the original equation.
So even if the point is negative, you go up.
Yeah, that's just literally the point. If you plug in, these are points that are on the graph. So we just plot those points literally. So,
You go -2.
yeah, you plot that point literally.
You don't go up first.
No, it's not a movement. No, it's just a point. Okay, are we okay with this graphing of vertex form, or do I need to do more?
You have one more.
Is the green in between the two marks on the red?
Is the green in between?
Like the vertex, not the vertex.
The red is between the two green ones.
I know, but like the two green points that you plotted.
Yeah.
Like the one on the right. And
Yeah.
in between, like -2 or like -1 and 2.
Oh yeah. I see what you're saying. Like on the, yeah.
Because it's not a very.
Right. It's technically getting the parabola is getting wider. The 1/2 makes it wider.
Wait, so what's that? -4 and -2?
Yeah.
So why be straight if it were 1?
What?
If it were 1, so why be straight?
If it were 1.
Yeah.
What do you mean? Okay. So can I start standard form?
Yeah, let's do that.
Standard form. Okay, standard form. Now, standard form is not much different than vertex form in the way it looks. But when you get to the graphing part, you're doing the same thing. Okay, so standard form. This is the way standard form looks. So your f of x, so your function of x, looks like a x squared plus bx plus c. Okay, and this standard form is generic for all polynomials. Okay, so that means if I had something really complicated like an x to the 5th, it would go x to the 5th plus x to the 4th plus x to the 3rd plus x squared plus x all the way back to the constant. Okay, so do you see how every time we're just losing an x on every term? Okay, so quadratics are a little simpler because there's only 3 terms. Yes. Can you wait 10 minutes? Yeah, you can. That was a yes. Okay, so we still have to find the vertex, right, in order to plot a parabola.
Yep.
Okay, so our vertex is still going to be h and k. But the way we go about finding them is going to be slightly different. Okay, write this down. You need to write this down. Everybody write this down. The h value, you are going to use a little formula called -b/2a. Okay, so that little expression helps you find the value of h. To find the k value, all you're going to do is plug the h value into the function. Okay, notice I wrote that as a function notation, f of h. So if you need to tell yourself, plug h into the function. That's what that is saying. Okay. Yes.
Quick question, so when you like drag all over the thing, does it stay there?
In OneNote?
Yeah.
Yes. Everything is in there. Okay, are we ready for an example?
Think so.
Okay, so we're still doing the same thing. We're just simply graphing our parabolas. Okay, this time though, I'm going to give you a function that's written in standard form. Okay, so let's say our equation is f of x is equal to 2x squared plus 8x minus 3. Okay, so this is a standard form quadratic. The a value is the same a value from vertex form. So your a value is 2. Yes. Okay, ready? How do I find h? What's that little expression that I use? -b/2a. So in the given equation, what is my -8 over 2 times what is the a value? 2. Can we all agree that -8 divided by 4 makes -2. Okay, now I need to find the k value. How do I find the k value? Very good. So I go 2 times -2 squared plus 8 times -2 minus 3. Okay, so I simplify this. On my first term I have -2 squared, which is close, 4, and 4 times 2, so 8 on the first term. If I have 8 times -2, what's that? So can I say minus 16? Minus 3. So what is 8 minus 16? -8 minus 3? -8 minus 3.
Oh.
-11.
Oh, my bad.
You're okay. It happens to the best of us. Alright, so what we just found is that our vertex is the point -2, -11. Which is not a great vertex because I made this point this up, but we can work with it. Okay, so if I asked you to graph this, you would start at the point -2, -11. So I'd go to the left 2 and down 11. Perfect. Okay, so I'm going to use V to represent the vertex, so my vertex is -2, -11. Okay, now all I need is 2 additional points. So how would I go about finding those? There's 2 ways. Absolutely, I can plug in a number. So what would be a good number I could plug in? -1 would be a great number. I'm not going to do that this time. How else can I do this? I can use the slope. So what is the slope? 2, okay? That just comes from this value in front of the x squared. So from my vertex, I'm going to go up 2 over 1. Okay, so up 2 over 1. Where do I land? What's that point? How about -1, -9? Okay, if it helps to draw your axis of symmetry, you can do that. Okay, if I reflect the point -1, -9, where would I land? Not quite that far. There you go, -3, -9. Okay, and then I can just draw that parabola. How do we do there?
Better than the other one.
Interesting. Usually it's the other way around.
This one's fine.
This one's what?
This one involves more steps, I feel like.
It does. Yeah, you have to find the h and the k instead of pulling it straight out. Yeah. So, do I need to do another example of graphing from standard form? Everybody's okay? Feeling good? All right.
Yep.
See.